Hi, welcome back. Let's talk about Wi-Fi standard and regulations now. The first one is ITUR, which stands for International Telecommunication Union for Radio Communication. ITUR is an international telecommunication regulatory body which regulates and decides which part of RF spectrum should be used for a particular purpose and how it should be used. When we talk about RF spectrum, we mean a very large frequency range. RF stands for radio frequency. RF spectrum starts from 3 Hz and goes up to 3000 GHz. So let's say if this is the RF spectrum and it starts from 3 Hz and goes up to 3000 GHz. So this RF spectrum is divided into several small frequency groups which are known as RF band. The first RF band starts from 3 Hz and goes up to 30 Hz. There are several other frequency bands as well. So we have another frequency band here which is known as UHF, which starts from 300 MHz and goes up to 3 GHz. This UHF stands for ultra high frequency. The other frequency band, which starts from 3 GHz and goes up to 30 GHz, is known as SHF, which stands for super high frequency. This last band is known as THF, which stands for tremendously high frequency, which starts from 300 GHz and goes up to 3000 GHz. Now these frequency range have their particular purpose. So the first frequency range, which is known as ALF, is used for submarines. The frequency range is very low here, so that means the wavelength will be very high because the frequency is inversely proportional to the wavelength. Frequency is denoted as mu and wavelength is denoted as lambda. So mu is inversely proportional to lambda. So if the frequency is low, that means the wavelength will go high. So that means that this frequency range can travel up to several kilometers and it can travel up to 10,000 kilometers. This frequency range is used for submarines where we do not have repeaters or antennas for miles which can receive the signal and retransmit. The other one is UHF, which starts from 300 MHz and goes up to 3 GHz. This band is used for mobile communication and wireless LAN communication. Mobile and wireless LAN. So if you see in this band, we have 900 MHz, which is used for second generation of mobile communication. We have 18 MHz, which is also used for second generation of mobile communication. And we also have 21 MHz, which is used for third generation of mobile communication. Now in this frequency band, we do have 2.4 GHz as well, which is known as ISM band. It stands for Industrial, Scientific and Medical Band. According to ITUR, this band is free to use, so any user who wants to use wireless LAN communication and using 2.4 GHz band can use it without any license, while these frequency bands require a particular license. So you must have seen that mobile operators buy frequency band first. The next band is SHF, which stands for super high frequency. It starts from 3 Hz and goes up to 30 GHz. In this band falls the 5 GHz range, which is again used for WLAN communication, which is again a unlicensed band, which can be used without any license. And the last one, THF, is used for experimental medical equipments and remote sensing. It's again a licensed band and you should buy a license before using this band. ITUR even keeps track of geostationary satellite communication as well. During this course, we will be mostly discuss about 2.4 GHz and 5 GHz because in these two bands only the WLAN communication works. And these both bands are free to use. As I mentioned earlier, ITUR is an international body. ITUR is followed by national bodies like FCC and ETSI. FCC stands for Federal Communications Commission, which works in United States. So what FCC does is it regulates RF frequencies, channels, and transmission power in US region. So in short, FCC tells which frequency band we can use and with how much power RF signals can be transmitted from an antenna, which is known as EIRP. EIRP stands for Effective Isotropic Radiated Power. EIRP is the net power level that is being transmitted from an antenna that is connected to a transmitter. So according to FCC, 2.4 GHz, which is also known as ISM band, is free to use for the users in US. And the 5 GHz band is further subdivided into 4 categories. These categories starts from 5.15 GHz and goes up to 5.825 GHz. The first band of 5 GHz is known as UNI-1 band. The second one is known as UNI-2 band. Third one is UNI extended and the fourth one is UNI-3. And these are the frequency range of these bands. The first band can be used for indoor purpose only. The second band can be used for indoor and outdoor purpose both. Third band is also can be used for indoor and outdoor purpose. And the fourth band is again a ISM band, that is for industrial, scientific and medical purpose. All these 4 bands are free for use in United States. And these are the maximum radiated power for the antennas for these bands. For UNI-1 band, you cannot go beyond 23 dBm. And for UNI-3 band, you cannot go beyond 36 dBm. ETSI is the European Telecommunication Standards Institute. What FCC does in US, the same is done by ETSI in European countries. So, it regulates RF frequencies, channels, transmission power in European region. According to ETSI also, 2.4 GHz is also used for ISM and it is free to use, which is unlicensed. And the 5 GHz is subdivided into 4 categories, just like in FCC. So the first one is UNI-1, the second one is UNI-2, UNI extended and UNI-3. But you can see the difference here. UNI-1 is used for indoor purpose only. UNI-2 is also used for indoor purpose. UNI-3 is also used for indoor and outdoor purpose. So the main difference here is UNI-3 is licensed here. That means we cannot use UNI-3 until or unless we have the license from the government. While in FCC, the UNI-3 was also free and it was known as ISM band. So this is the main difference between ETSI and FCC. We do have other regulatory bodies as well, like BRAI in India. BRAI stands for Broadcast Regulatory Authority of India, and NTT in Japan. NTT stands for Nippon Telegraph and Telephone. So the purpose is the same. They maintain and broadcast the RF frequencies in India and Japan. IEEE is a standard which stands for Institute of Electric and Electronic Engineers. What IEEE does is creates and maintains industry operational standards. IEEE has several standards like IEEE 166, which is a standard for C programming language referral manual. Likewise, IEEE also has 802 standards. These 802 standards mainly deal with physical and data link layers of OSI model. This 802 is known as working group, and .1 or .11, these are known as family member. So the 802.11 will be read as working group 802 and family member 11. The wireless LAN falls in 802.11 standard, and in 802.11 standard, RF media acts as layer 1 and TX-RX wireless data frames acts as data link layer. So whatever the data which we are sending goes over these signals, which are RF signals, and these RF signals are known as layer 1, which is the physical layer for this communication. And the frames which travels over these RF signals are known as data link layer, which is layer 2, data link layer. This 802 standard also has Ethernet, link layer control, token bus, and network bridging. But in this course, we will mostly discuss about 802.11, which is used for wireless LAN. I hope you learned something new today, and thank you for your time.